Hello, it's dumplet here. Here's an item on number theory. A three-digit number has the following property. The three-digit number equals 19 times the sum of its digits. Find the largest possible three-digit number. Now credits to the Southeast Asian Math Olympiad for this item. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Now, whenever we have an item in a competition that uses the fact that we're going to compare something to digits of a certain number, like in this case, we can try to make use of the following way to represent that three-digit number. For example, if I have 243, we're going to make use of what we call place values. So that the 2 here, it's going to represent 200, the 4 here represents 40, and the 3 here represents 3. So we can technically write this as 100 times 2 because that's going to represent 200. If you expand this, that's going to be like the value of the 2 here. So this is like the 200. And then the plus 10 times 4, that's going to become 4 is the 10th place value. So this is going to represent 40. And the ones digit 3, well, that's just obviously going to be 3. Now we can do the same for generally a three-digit number with hundreds place A, tens place B, and then ones place C. So we can do the same here. Instead of actual numbers, we can write this number, a three-digit number, as 100A plus 10B plus C. And this is going to be like the algebraic way to represent a three-digit number. Now we want to compare this to the sum of its digits, 19 times the sum of its digits. So 19 times, well, the digits are just A, B, and C, so this is going to be simply A plus B plus C. Now with the distributive property, we can easily distribute the 19 to the A, B, and the C, and we're just going to form the equation 100A plus 10B plus C. That's going to equal 19A plus 19B plus 19C after the application, just using the distributive property. Now here, we can simplify stuff down because we have A, B's, and C's here. So for example, for the A's, the 100A and the 19A, we can subtract both sides by 19A to eliminate at least A on one side. So subtracting both sides by 19A, we're going to end up with 81A. And then just simply copy the rest, and then you can easily see that we're going to do the same for B and C over here. So after subtracting 19A on both sides, maybe we want to work on the B's. So see that we can subtract both sides by 10B plus C already. We can subtract both sides by 10B plus C, and we're simply going to end up with the equation that 81A, that's going to simply be equal to 9B plus 18C. And it's a more simple equation to work with. We can simplify this a little bit more. We can divide both sides by 9. We're just simply going to work with 9A equals B plus 2C. Now, we're going to take into consideration now this equation. Alright, so 9A equals B plus 2C. Now we're asked to get the largest possible three-digit number. So obviously, if we want to have a large three-digit number, the hundreds place should be quite large as well. So there must be a restriction for what A here can be, and that's going to obviously depend on this. Now recall that A, B, and C, they're all digits, so we can kind of think of what's the maximum value. For example, what's the largest possible value of this? Well, obviously, if I want A to be a very big number, then I should be able to maximize this. So what's the maximum of that? Well, that's going to be when B and C are at maximum, which is 9, because they're digits. So B and C are equal to 9. Now, if both of them are equal to 9, I'll be getting 9 plus 2 times 9. That's going to be 9 plus 18. So that's going to be 27. So I know that B plus 2C is less than or equal to 27. So I would have 9A is going to be equal to something that is less than or equal to 27. So I can just immediately tell you guys that 9A is less than or equal to 27. Dividing both sides by 9, I would get that A is less than or equal to 3. Now obviously I want to maximize stuff, so I'm going to take the equal sign here a equals 3. And let's see what we will get if a equals 3. All right, if a equals 3, I'm going to directly substitute. So 9 times 3, that's equal to b plus 2c. 9 times 3 here, that's equal to 27. So 27 equals b plus 2c. But we already mentioned in the past that b plus 2c is less than or equal to 27. And we know that the maximum is going to happen at b and c both equal to 9. Well, the maximum is 27, so it must be the case that b equals 9 and c equals 9 over here. And you can easily check that if b equals 9 and c equals 9, substituting it back here, you're going to get that this equation, it's indeed going to be true for a equals 3, b equals 9, and c equals 9. Now, since we've considered that a can only be at most 3 from the previous example, from the previous part here, so we can actually conclude that the largest 3-digit number is going to be 399, and this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.